In Chapter 7, we've got yet another probability distribution. We're going to talk about the t-distribution in this chapter. And in this video, we're just going to get some practice utilizing it, utilizing our t-tables to, in this case, find some critical t-scores. So we're going to start with number 1 here. It says find the critical t-score for a 95% confidence interval, and n is equal to 10. I'm going to start by talking about my confidence level first. So it says a 95% confidence interval. Now, if I was to go and sketch this curve, I know that the student's t-distribution looks relatively similar to the normal distribution. Of course, there's some differences here, but in particular, it's unimodal and symmetric. For our purposes, the rough sketch will look pretty identical. And when I look at a confidence interval, in particular my confidence level, my goal is to capture the middle 95% or 0.95 of my sampling distribution. I want the area in the middle to be 0.95. Now when I go to look at my table here in just a moment, it's going to ask me about the area in the tails, either the area in one tail or the area in two tails. And we can kind of think about it from either point of view. I think it's actually easier to start with the area in two tails, because if I look at the area in both of these tails together, I know that that's 1 minus the area in the middle, which is 0.95, to end up with 0.05. So the area in two tails is 0.05. I could, if I wanted to, just cut that in half, since I know that this curve is symmetric. I know that the area in just one of those tails then would be 0.05 divided by 2 to get 0.025 in both the right and the left side, so 0.025. So in a second, when we jump over to the table, we can either use a two-tail area of 0.05 or a one-tail area of 0.025. It actually doesn't make a difference. It'll actually be the same numbers that we're looking at. So either one of those is fine. The other thing that we're going to need to talk about then is the degrees of freedom. So this tells me n is equal to 10. Just like with our chi-square distribution, our t-table is going to utilize degrees of freedom. However, the way that we calculate degrees of freedom is a little bit different this time around. So degrees of freedom, the formula is actually a little bit easier to work with, I think. Degrees of freedom is just n minus 1. So in this case, 10 minus 1, we have 9 degrees of freedom in this case. So we have 9 degrees of freedom in a two-tail area of 0.05 or a one-tail area of 0.025. We should have everything we need then to go ahead and look at our table. So I'm going to hop over there real quick. So we said, first of all, 9 degrees of freedom. If you look at our table, first of all, it should look pretty familiar to what we've been talking about in the chi-square table, where we have over here on the left-hand side, we've got all of our degrees of freedom. So we're looking at 9 degrees of freedom, which means we really only need to pay attention to this row right here. And then if I look at the pictures above, it actually kind of shows you the left tail test, the right tail test, and the two tail test, whether we're talking about one tail or whether we're talking about two tails. If I look above right here, this row right here above at the very top is going to show the area in one tail and the area in two tails. And we said the area in two tails was 0.05, or if we thought about it as a one-tailed area, that would be 0.025. So it's the same exact column, doesn't really matter. I know that that's the column that I'm looking at. And then, of course, I want the intersection between those two. So in this case, my critical T star will be 2.26. So if I hop back to my problem here, my T star was equal to 2.26. There it is. So we really need to think about what is our degrees of freedom, and then what's either the two-tail area or the one-tail area. It doesn't matter which. They both get the job done. So in the next problem, number 2, it says find the critical t-score for a 99% confidence interval and n equals to 58. So first of all, let's find our degrees of freedom. That's 58 minus 1. We have 57 degrees of freedom in this problem. And I know if I was going to sketch out what this distribution looks like, I want the area in the middle to be 0.99. I'm going to think about the area in both tails together just because it's a little bit less work here. If I think about the area in the both tails, the two-tail area is always 1 minus my confidence level. So in this case, 1 minus 0.99 to get 0.01. So the two-tail area would be 0.01. You could also cut that in half to find the one-tail area. It should be 0.005. But at this point, again, I have everything I need. I've got my degrees of freedom. I've got my two-tail area. Let's hop over to our table. So in this case, we said 57 degrees of freedom. So let's scroll down here. We're going to look for 57 degrees of freedom. And I have somewhat of a problem here. If I look over here at my degrees of freedom, I know that my 57 degrees of freedom should be somewhere between 50 and 60. But our table isn't quite as detailed. It's not going to have every single possible case because we've got theoretically an infinite number of different sample sizes that we could use. So they're not going to list them all. At some point, they start to get too big. We're going to scale by 10s or even 50s or 100s. So if I look at this, when we talk about degrees of freedom, you are only ever allowed to go down for degrees of freedom. You are not allowed to go up. So in this case, even though normally I would say, well, 57 rounds up to 60, when we talk about our degrees of freedom, we always go down. So 57 does not appear in our table. The next highest number that we use, though, is 50. So we're going to be looking at this row right here. So we're looking at 50 degrees of freedom. This is the row that I want to use. And then we said we had a 99% confidence interval, which means a two-tail area then of 0.01. So this is what I'm looking at, which means that my critical T star for this problem would be 2.68. So my T star being 2.68 right here. Let's go ahead and mark it down. T star in this case is 2.68. There we go. Let's have a look at one more real quick just to get comfortable with it. If you want to, I would recommend pausing the video, just trying to see if you can find that critical T star value for yourself and giving that a try, and then coming back and watching the video and checking your work. So I'm going to assume at this point you've paused, you've tried the problem. So n in this case is 80, which means that my degrees of freedom is 80 minus 1 would be 79. So I have 79 degrees of freedom right here. The other thing I need to look at is my confidence level. We said we have a 90% confidence level. So I know that the area in the middle should be 0.9, which means that we're going to have a two-tail area. If I look at the area in both tails, it would be 1 minus 0.9 to get me 0.1. So the area in two tails is 0.1. My degrees of freedom are 79. We should be ready to go and answer this question. So hopping back to my T-table one last time here. So let's erase this highlighting that we've done already so that we don't get confused. We said our degrees of freedom was 79. Again, we're going to look right here. It's going to be somewhere between 70 and 80. It doesn't show up. Even though 79 is really close to 80, we cannot round up for degrees of freedom, which means that we're going to be looking at this row right here for our degrees of freedom. And then we said we had a 90% confidence interval, which means we have a two-tail area in this case of 0.1. We're going to be looking right here. So this is the column that we want. So my T star in this case is 1.67. So the T star that I'm going to use, and I'll mark it down just to finish this up, T star is equal to 1.67. So this is going to be a really important skill for us moving forward because it's going to be a step that we have to use when we're building our confidence intervals for means, and then later on when we talk about hypothesis testing for means, we're also going to be using this T-table.